Hello, welcome back to my shop. Several months ago, I came up with the idea that I wanted to make a talking frequency counter for a blind ham friend of mine. I've got a radio for him. It's a FT757 GX and an automatic antenna tuner. The thing has the ability to show on a computer screen what frequency you're on and what band you're on, but it's only one direction. It tells the radio what to do, but it doesn't talk back to the computer, so you're never really sure what you're doing. Now, he can read the screen with his screen reader, but he's not going to be absolutely positive that he's on the right frequency. So I thought, maybe I can make a talking frequency counter and he can just key it up and it'll tell him where he's at. I thought about it for quite a while and finally decided, well, maybe I can do this with an Arduino. So I searched around and I found an Arduino voice library that actually puts the sounds out in PWM, pulse width modulation, and it sounds fairly good as far as hearing goes. It's not perfect. It's not quite as good as Perfect Paul or whatever they call that for the NOAA weather radio, but it works. So this little video is the story of me building that device. I hope you enjoy it. Okay, well, we started off the project by breadboarding up a little Arduino and the frequency counter library that I found online, and it does work. This is showing about 1.4 megahertz, and you can see that it's off a little. The frequency actually is fully dependent on the programming and the division or multiplication of the input, which is fine. Here we're doing 2 megahertz, and you can see that it's off. It's 1,999,816. So it's off a little bit, but that's okay because I can make up for that. But at least we've proved that the frequency counter library does work. As usual, when I put this thing together, I kind of got carried away. I put it on my digital trainer here because it has a frequency generator and all the voltages that I need. And, well, now the whole thing does a whole lot more. The buttons up there on the right, the blue one is for frequency. The white one next to it is for the frequency multiplier. The red one is for ohms readout, and the green one is for voltage readout. It works. The little blue pots up there on the left are for the voltage or the ohms adjustment. I really need to get better pots for that because those are pretty awful. But it does work, and after a whole lot of programming and back and forth to try to get it right, I finally got it so that it would read out, and it's our first test of the voice to see how that sounds. And here's what I got when I pushed the buttons.
999,904 hertz. 0 millivolts. 1,011 ohms.
Okay, so now we know the concept is good and that things work. So all that's left now is to put together all the parts on a little PC board and make it work. As you can see by this picture, I actually added a couple more buttons to it. Yeah, I know, keep going. But those buttons are not going to be in the final version. The yellow button on the far left side is for an information thing just for me that tells me where everything is set. Where the multiplier for the frequency is set, where the ohms is set between 1K, 10K, 100K, 1000K, 1 mega ohm. And the red button next to that is for volume control. I'm not going to have a volume control in software on this. I'm going to have it as a little amplifier. But for this particular thing, it works. And I've got it working. Now we just got to build up all the parts for it and see where we're at with that. Okay, so the first step is to make a PC board. In this case, we're going to use the old-fashioned method of designing a PC board in a program, printing it out on a piece of glossy magazine paper. As it turns out, all you need to do is get a good piece of glossy paper, and you can heat transfer the PC board schematic or diagram onto the PC board there. And as you can see, it's a couple inches, and that's about it. So my heat transfer method at this point is going to be an old iron. Here it is, sitting atop the PC board with the glossy piece of paper underneath of it and some caftan tape holding it down so that the tape doesn't melt. And we're letting it sit for what seems like a very long time. Well, I found out later that it really is a very long time. It says between 5 and 10 minutes in the instructions that I read, but it was more like 15, 20 minutes, but that was because I didn't do it right. So we went back and used a real piece of transfer paper that has the good stuff on the other side, and not just a piece of stuff out of a magazine. This is transfer paper I got off of eBay, and it's kind of yellow, and I've got it turned down onto the PC board here, and we applied more heat to it for a good 15 minutes anyway. And after a very large pop, I took it off and pulled off the paper and stuck it into the bath of ferric chloride and let that sit and jiggle. You'd have to jiggle it around for a while to make sure it works, but eventually you keep doing this and you'll get a PC board that looks like this. It's not perfect. There's some parts that are not etched away, but they're not contacting anything else. And I did it too long. I heated up that board way too long, and as a result, we'll see later that I had some problems with it. But it worked, and now I have a PC board to play with. As you can see, the IC part of it, that little IC, that SOP service mount part, came out real nice. The rest of it, not so good, but it's there and it works. Okay, the next step, of course, is to drill holes in the PC board. For this, I have a Dremel and I think they call it a workstation, but basically it's a Dremel drill press. I used a 1/32 inch bit, and it works. The holes are about right, but the bit's really cheap, Chinesium, and you gotta spend about 10 minutes just straightening the thing out first so it doesn't wobble around in the hole. But it worked. I made it, and all the holes are drilled. Let's see if we can do this. Just made the board. Now we're going to see if we can solder these pads. Hard to do with the camera in front of your face. Okay. Those two are supposed to be shorted. Now let's get the solder wick and see if we can get some of this off of here. Oh boy. Yep, there it goes. This is some big fat solder wick. Got this on eBay. It was cheap, and there's a reason. It has no flux in it. Okay. So, how's that look? Pretty good. Well, now, let's see. Let's get the little chip. Let's see, the dot is lower right, lower left actually. And the dot on this is lower left. Okay. Get this centered on there as good as possible. Not very good. There it is. Oh. Okay, well, got one side of it tacked on there. Now let's see if we can get the rest of them on. This is pretty fiddly. But here, let's do the rest of them. These two are shorted together. That makes that easy. All right, let's take a look at it. Yep. That looks good. Let's get a ohm meter here. Make sure we haven't shorted anything out. No. Not there. Not there. Wow. Okay, well, we got that part. Now we got to put in the rest of the parts. You do notice, I presume, that I had a little bit of copper bubble up here and fall off, but that's okay. I can just do a jumper lead jumper here. That'll help. Anyway, we'll be back once we get the rest of the parts put in. Okay, well, we're back, and we got all the parts on the board. They all fit. The only mistake that I did here was the top of this Zener, the 5.1 volt reference Zener. I didn't drill a hole for it, and I didn't make a pad for it either, but I was able to just drill a hole right there and then go across it. There's where I'm going to have to just run the wire through it and wrap it around that leg of that transit or resistor. The little IC went on there nicely, and everything worked. So this is where all of the wires are going to come off that go to the switch for the different ohms ranges. Here's the ground. This is the voltage sense wire that goes out. That goes to A1. Here's J1, which is your power right here. And these are, this is VCC to go to the Arduino. That is goes to switch. This goes to switch 1, and this goes to A0. This is J2, which is the ohms. That's where the ohm sense goes. This line here goes up to these guys, and then this goes over to B+, well, the 5.1 volts. This is J3. This is the frequency input, goes through this capacitor here and over to the input of pin 1 on the divide by 64 counter. This is down here. This is for the volts measurement. Goes into this resistor, which is a dividing resistor. This side goes to ground. And we set that for exactly divide by 10. And the wire that comes out and goes to A1 is this. So A0 and A1. And these guys all go to the switch, and the output of the switch goes to the digital input. The different digital inputs for the resistance measurement, and this is ground. So there it is. The board's made. Not everything is perfect, but it's not bad for a prototype. Now all we got to do is see if it works. So, and the box I'm going to put it in is right here. This is a little box that was given to me. It's an interesting little guy. It's weird shape, but it's kind of a nice, I don't know, shape and feel to it. The board goes in there. I've got, where is it? I'm going to use this guy. This is going to mount on here. And this guy here goes right in there like that and slides under everything. And the Arduino, here's my blown up Arduino. The Arduino itself pull this out of here. The Arduino itself, I can mount to here onto the board like that, and then I can slide it in like this here, if you can see it right there. And then when I get it slid in there, take this switch out, get it out of the way, then the Arduino will be able to be, it'll be, wow, this is difficult. Anyway, the Arduino will be, come on, get out of there. Yeah. So it'll be right there. And I'll be able to get to the programming port to change programming on it if I want to. This power is not going to be used. I suppose it could be. But I've got a battery pack that I'm going to be able to slide in from the other end down here, and then on this side, and the batteries will be in there for 6 volts, and that'll be enough to drive everything. There's going to be drill a few holes in the top right here for the speaker, and if you look down, take this end of this box off of here. So if you look here, there's a little LM386 amplifier module connected to this pot, and it's just going to here's the speaker, and the speaker is just going to sit up inside of here like that, right there, with some holes drilled in the top for the sound to get out. So that's the idea. Going to have push buttons on the top to be able to push the button, and maybe I'm going to put 3 switches in the front, little blue toggle switches that basically just short out the switch so that you can flip the switch down or up. Yeah, flip the switch up, and it'll short out the top switch, and it'll just, the thing will keep talking. It'll just say, 6.8 volts, 6.8 volts, 6.8 volts, as fast as it can read it. This switch here is the ohms set for the different ohms values, and this switch, I was going to use that. I don't know if I'll use that or not. I was going to use that to replace the push button for the times. I don't know if I'll do that or not. A couple of switches I can get rid of because I've got a volume control here. I think I'm going to leave the volume set so I don't need the volume push button. I can get rid of that code. I still want the push button. I think I'll put the push button on the front for the info. So the info button will be here. There will be 3 switches to bypass the volts, ohms, and frequency. So it'll keep talking. And the push button for info, or maybe I'll put the push button for info. I don't know. We'll see when I get it done. And I'm going to put out back here a speaker port so that you can put it in a line out so that you can put it into an external speaker if you want to. And there's the on-off switch. It's a big on-off switch, but it's what I had. So when I get this thing and actually get the boards made for it, I've got a really nice little case to put it in that looks something like a instrumentation case with the handle on the front, so that you can put it down like a frequency counter case. So anyway, that's where we're at now, and we'll be back when we get some more done. Well, as it turns out, I went through a whole lot of steps and installed a bunch of parts, and drilled a bunch of holes, and got everything all in there, and it came together pretty good. But boy, that box is hard to work in. When I got it all done and put together and kind of in the final form, wouldn't you know it, the real box showed up in the mail. And here is my initial layout in the front of the real box. This little case was about $7.50, I think. And it got here faster than I expected. So what we ended up with was, over on the left is the volume control. The two red ones to the right of that are the ohms input. And the big knob in the center is for the ohms range switch. The two black and red ones are on the right there, top right, are for the voltage input, and the bottom connector is for the frequency input. That's the way it's going to be. As far as the front goes, the top buttons, the left one is ohms, the middle one is voltage, and the right yellow one is for frequency. Now we got to get everything mounted inside. Okay, so here's the here's the layout inside of it. The Arduino is mounted to that little perf board with the connector for the programming connector stuck out the back. The little board I built, the new version of the board, is over on the right, mounted to the perf board also, and screwed to the bottom of the case. Speaker is mounted over on the left. The big gaping hole in the back was my fault. I tried to drill too big of a hole in it first, but I'll cover that up with something. Power connector's over on the left. So now we got to do is get all the wires run on the inside and get everything hooked up and see if it works. Okay, here we go. All the stuff's inside the box. All little wires are run. All of the switches are connected, and there's wires all over the place. And as you can see, the little board's in there, the Arduino's in there, it's all mounted, connected to the speaker and the amplifier. And now all we got to do is check it all out and see what happens. We'll give it a test. Alright, so we've got everything hooked up. We've got a 1000 ohm resistor over here. We've got 8.5 volts going in there just as a test, and 1 megahertz going into here. Our voltage is coming from right there. It says 8.5 volts. Our frequency coming from a little generator right there, 1 megahertz. And of course our resistor. So let's see what it sounds like.
volts, 1012 ohms, 1,032 hertz.
Okay, so there you have it. Start to finish build of a little talking volt ohm meter with frequency counter using an Arduino and a couple of online libraries. Wow, well, that was fun. I don't know how much use this is going to be, but hey, it was fun trying. There's a lot of improvement to be made, and I'll keep working on it. But as a first attempt, I think this is okay. It works, and it solves a problem for a blind friend. And we'll give it to him and let him see what he thinks of it. Anyhow, thanks for watching, and I hope you enjoyed it. If you did, give it a old big thumbs up, and make sure you subscribe to my channel if you like this kind of stuff. Till next time.